again. Except for this one's different because we're going to have some different information. We're going to be given a population standard deviation. Remember, whenever we have sigma, we're going to be using z's. So that's why we see a z value here. And they're also going to still have to, just like before, give me a margin of error. So, again, just like before, this is a formula for the minimum sample size. So just like before, we're always going to round up no matter what, because this is going to give us a minimum value. So let's go ahead. How do we know that we're doing this? They say how many grade point averages must be obtained. That means we're looking for an N, a number, a sample size. So we've talked about two different formulas for this. One has p hats and q hats. And then this one has a standard deviation in it. So how do I know which one to use? Is they actually mention the word standard deviation. So there are two formulas, but one has p hats and q hats, and the other one has a standard deviation in it. So we're going to be using the one with the standard deviation in it. So we'll copy that formula, the n equals z sub alpha over 2. Both of them have a z sub alpha over 2. This is the only one with a standard deviation, though. The other one has p hats and q hats. So let's take a look at this formula. We already have the standard deviation. That's given. That's the 0.79 in the problem. Now, when they say that the sample mean needs to be within 0.2 of the population, that within part is actually telling us how close you need to be. Remember, that's what the margin of error tells you, how much above or below. So that means they're inadvertently giving me the margin of error as well. That's going to be your 0.2. The only thing we don't have is the critical value, the z sub alpha over 2. And remember, that's going to come from our confidence level, the 99%. So let's figure out what that z value is going to be by drawing our normal curve. Remember, if it's 99%, that's what's going to be in the middle, is the 0.99. Okay, which means that each n, the n's together then will be the other 0.01 or 1%, which means each n is going to be half that, which is going to be each n is going to be half of that, which is 0.005. Which means to find this, remember we're back to z values, we need all of the area to the left, which means I'm going to take the 0.005 and the 0.99 and add those up, which will give me a 0.995. And I can either use my normal distribution table, or I can use the inverse norm in my calculator. And remember, the inverse norm only needs the area to the left that we came up with, which is the 0.995. It's not like the inverse t. We don't need to give it degrees of freedom. We can just give it this. And what do we come up with for our z? We'll get a 2.58, depending on how we round, and this is our z that we're going to use in our formula. So that was the main part of our work. Let's continue. So now let's continue along with our formula. We had our n equals, and we had our z sub alpha over 2, our sigma over our e, and then this whole thing was squared. Well, we just found out our z sub alpha over 2 was our 2.58 times our sigma, our standard deviation, which was given in the problem, which was 0.79, divided by our error. Our error was given to us in the problem. That was the 0.2. And then don't forget, this whole thing is supposed to get squared. So order of operations is going to make sure that you do what's inside these parentheses first, which means you should be multiplying the 2.58 and the 0.79 first, then doing the dividing by the 0.2, then doing that squared at the very end. You have to do what's inside the parentheses first, though. Then do your squaring at the end. That will get you a 103.9. Again, be careful. This is your minimum sample size needed. So we always have to round up, which means that I'm going to round this up. No matter what the decimal is after the point, the 103 is, I'm always going to round it up. So I'm rounding up to the 104. That is the minimum sample size needed. So we do have two formulas for sample